A giant camel once roamed above the Arctic Circle, in a forest, in the dark. That's not myth or legend. In 2013, a team from the Canadian Museum of Nature, led by paleobiologist Natalia Rybczynski, pulled 30 fragments of a single leg bone from a steep hillside above Strathcona Fjord on Ellesmere Island, Nunavut. A bone 30% larger than any camel walking today. Collagen locked inside it, the one material durable enough to survive 3.5 million years, tied the animal to the same family line as the camel in your nearest zoo. The ground around that bone held more than one animal. Alder leaves, larch needles, the tracks of bears, beavers, and badgers, sharing a forest with a camel found nearly 1,200 kilometers north of any other known camel fossil on Earth. Take a breath. The air now filling your lungs carries almost exactly as much carbon dioxide as the air that animal once breathed, somewhere between 380 and 420 parts per million. Then and now. That camel wasn't a lone traveler that wandered too far north. It lived inside a forest that reached across the rim of the Arctic. In northern Alaska, the same period buried pollen from spruce and birch in rock that geologists say once looked like present-day Anchorage. Not tundra, an actual working forest, well north of where any tree grows on that coastline today. The Arctic wasn't the exception, either. 3 million years ago, global sea level stood at least 15 meters higher than it does now, enough to put much of Florida, Bangladesh, and the Netherlands underwater. Antarctica's ice sheet was smaller. Greenland's was barely there. Near the poles, the ground itself tells the same story. Permafrost, the layer of soil frozen solid for thousands of years today, covered far less ground than it does now. Every proxy paleoclimatologists have ocean sediment cores, ice-rafted debris, ancient soil chemistry points to the same conclusion from a dozen directions at once. This was not a different planet. It was this one. Same sun, same tilt, and almost the same amount of carbon dioxide we are pumping into the sky right now. Something took a warm, forested, nearly ice-free Earth and locked half of it under ice for good. Whatever did that has never fully let go. No one is arguing about whether this happened. The argument is about why it stopped. You probably think an ice age starts with a wobble, Earth's orbit tilting or drifting until it finally tips the planet into a colder rhythm. That wobble is real, and it has a name. Milankovitch cycles, after Milutin Milankovitch, the Serbian engineer who worked out the mathematics of it while under arrest. He was interned in Budapest for most of the First World War, paroled into a library, and used 4 years of forced stillness to calculate exactly how Earth's orbit rocks and tilts over hundreds of thousands of years. That wobble has been rocking Earth's orbit for hundreds of millions of years. It didn't start 3 million years ago. Something else did. Start with the ocean. For tens of millions of years, a break in the Americas let warm equatorial water pass freely between the Atlantic and Pacific. Then, as the Panama tectonic plate crumpled and rose, that gap began closing. Warm, salty water that once slipped through was forced north instead, strengthening what we now call the Gulf Stream, and pushing more moisture toward the Arctic. At the same time, a much slower process was already underway. Across tens of millions of years, rock exposed by mountain building, the Himalayas, the Andes, had been chemically weathering, pulling carbon dioxide out of the air and locking it into stone. Atmospheric CO2 fell from over 400 parts per million toward 300 and below. Neither change was, by itself, enough. More moisture reaching the Arctic without falling CO2 would have delivered rain, not permanent snow. Falling CO2 without that moisture would have starved the ice sheets of the material to build with. Ice sheets don't grow gradually in proportion to their cause. Once conditions cross a threshold, they can lock in fast, and stay locked in for good. That's the mechanism this entire system runs on, in miniature, slow preconditions building for millions of years, invisible until they cross a line, and then a planet that no longer resembles the one before it. The timing of the ocean side of that story is genuinely disputed. The traditional account follows a 1998 study by Gerald Haug and Ralph Tiedemann. It dates the Isthmus of Panama's final closure to around 3 million years ago, lining up neatly with the ice. But a 2015 study led by geologist Carlos Jaramillo challenges that date, examining fossil trees and sediment from the Panama Canal excavation itself His team argues the isthmus was substantially in place 10 million years earlier than that. If Jaramillo is right, the ocean gateway can't be doing the work the traditional story gives it credit for. The falling carbon dioxide may be carrying more of the weight than anyone assumed. But if ocean circulation had already reorganized by then, there's a stubborn gap in the story. Sediment cores show the Atlantic and Pacific were already chemically diverging, the clearest sign of that ocean shift, by 4.2 million years ago. That's 1.5 million years before any ice sheet actually appeared. The ocean did its part early. The planet waited. The wait ended in a specific place, around 2.7 million years ago. 3 separate orbital rhythms: the tilt of Earth's axis, the wobble of its spin, the stretch of its orbit, happened to align, giving the high Arctic several unusually cool summers in a row. That's the same wobble Milankovitch calculated from his library window in Budapest, and on its own it had done nothing for millions of years. What was different this time was what it was acting on. By 2.7 million years ago, atmospheric CO2 had finally fallen far enough. A cool summer no longer just delayed the next thaw. It left snow behind that never fully melted. One unmelted layer became a base for the next winter's snow. Reflective white ground cooled the air further, inviting more snow. The ocean's moisture, the falling carbon, and one well-timed orbital coincidence locked together, and Earth crossed a line it had spent millions of years walking toward. 3 million years ago, this was a warmer planet. Camels in the Canadian Arctic, forests in northern Alaska, seas 15 meters higher, and roughly the same carbon dioxide in the air that we're breathing right now. Not an exception, not a fluke season. The normal condition of that stretch of Earth's history. That warmer world held for another few 100,000 years. Then, quite suddenly, around 2.7 million years ago, 3 things arrived at once. A slowly closing gap in Central America had rerouted ocean currents. Tens of millions of years of mountain building had finally dragged CO2 below a critical level, and a precise temporary alignment of Earth's orbital wobbles turned a handful of unusually cool Arctic summers into snow that never fully melted. One unmelted layer became a floor. That floor never went away. The pattern gets bigger than one continent. The same collision of continents that built the Himalayas and the Andes, mountains still rising today, is still pulling carbon out of the sky, on the same timescale it always has. It's also why climate scientists keep returning to this exact stretch of the past, not as trivia, but as the closest real preview we have of where today's atmosphere is headed. Meanwhile, in the last 200 years, humans have started pushing that number back the other way, faster than any orbital wobble or mountain range ever has. Atmospheric CO2 has already climbed past 420 parts per million. Back inside the range that opened this story, the range that Camel once breathed, and the ice sheet sitting on Greenland right now isn't some permanent fixture of this planet. Nor is Antarctica's, even though that one is far older. They're temporary states, held in place by a chemistry we are actively renegotiating. Whatever climate you were born into is not a fixed backdrop. It's the current position of a system still very much in motion. The ice you picture when you picture Earth was never the default. It's a fragile state this planet spent tens of millions of years building toward, held in place by a swing of little more than 100 parts per million of carbon dioxide. And the same breath that once matched a warm, camel-forested Arctic is, right now, quietly and steadily taking it apart again.